Okay, we're going to talk today about transformations. So we're going to take different functions, different what we call parent graphs. We're going to look at absolute value functions. We're going to look at quadratics, which we studied both of those quite a bit in the fall. And we're going to learn how to look at the algebra and determine how it has been transformed, how those parent graphs have been altered, changed. You can tell they're in the same family by their appearance, but we're going to see that they've been shifted, or here's some key vocabulary words. We're going to learn how to shift both in a vertical and a horizontal direction, which means simply we're just going to shift it. We're going to move it left or right or up or down. We're going to take a function and we're going to learn how to do the algebra to make it what we call stretch, either vertically or horizontally. So a vertical stretch would be like taking the top and the bottom, and we're going to stretch that so that the appearance of that parent function would look like it would get thinner or skinnier or taller. Or we could take it horizontal, and we could take it in each of the sides of it and pull it or stretch it horizontally from left to right, and thus the graph would seem to get wider, or it would get pulled from left to right in a more extreme fashion. Or we can take those also, and we can take vertically, and we can do what we mean by compress. We can take the top and bottom of the function and we can squeeze it. Again, it has the same geometric or physical effect that a horizontal stretch would. Get wider looking, but again, that would be a compression, a vertical compression. Or we can take it from side to side on the horizontal side and compress it in, making that function again look squeezed from side to side, from left to right, which will have the effect of it looking like it's getting skinnier or thinner or taller. So those stretches or compressions can be confusing in their appearance, but not so in the algebra. And so we're going to learn how to identify and how to manipulate the algebra of the parent graph to get it to do what we want it to do, because today we're going to look at algebraic artwork. We're going to look at some functions and how they appear in a parent graph form, and then you're going to learn how to transform them. A third transformation, to review, we've talked about shifting vertically and horizontally. We've talked about stretching and compressing. Those are kind of the same things, both vertically and horizontally. And then the third type of transformation we're going to do is we're going to flip or reflect. We're going to learn how to take the algebra and reflect it vertically, which would be reflecting it over the ground or over the x-axis. Anything that was below the x-axis will be reflected up. Anything above in the graph, in the parent graph, will be reflected down under the x-axis. Or we're going to learn how to vertically or horizontally reflect, which will reflect over the y-axis or the vertical axis. And so anything on the left side of the vertical axis in reflection will be reflected over on the right, and anything on the right-hand side then would be reflected over on the left. And so we're going to learn how to do that. We're going to have to learn how to manipulate the algebra to get those parent graphs to do what we want to. We're going to see what they look like as a parent, and then we're going to learn to shift, to compress or stretch, and then also to reflect and put some functions together to make some artwork. So create some geometry or some art piece that has been determined and affected by the algebraic functions. So we're going to look at those. We're going to look at those Tuesday, and learn how to become experts at that, to create some algebraic artwork. I hope you've had a great winter break, and the Christmas season was wonderful time with family, and the New Year's was a celebration. And so I hope all those things happened, and we'll see you Tuesday.